Okay, let's take a look at group problem 1. So it says to evaluate each sum and determine the interval of convergence. So right away, we notice kind of a weird looking series here, right? Starting at 0 going to infinity, that part's fine. Cosine of x, that quantity raised to the n power, right? So what does that look like? So again, let's look at the first few terms, right? Just to kind of get a sense of what's going on here. So the first term is cosine of x to the 0. Then we would get cosine of x to the first, cosine of x squared, etc., etc. Okay, and so what we've really got here is, we're just, looks like we're multiplying by a cosine every time, right? So we start with 1, because that's anything to the 0, right? Plus cosine of x, plus cosine squared, plus cosine cubed, etc., etc. Okay. So we can treat this like any other geometric sequence, right? A sub 1 is going to be 1, and the r value here looks like we're multiplying by cosine of x each time, okay? So what is the sum of this infinite series going to be? It is going to be 1 over 1 minus r, which is cosine of x. Okay, so there's the answer for the sum. Okay, and now the interval of convergence on this one is a little odd, right? So again, we want r, right, the common ratio to be, right, its absolute value to be less than 1. Okay, and so for this one, it gets a little goofy, right? That means we want the absolute value of cosine of x to be less than 1. Well, if we think about it like the last one in terms of an interval, right, r has to be between -1 and 1, right? And so cosine has to be between -1 and 1, right? So what values of x make cosine between -1 and +1, right? Well, basically anything that, all of the x values except the ones that make it equal to 1 and -1, right? Because the range for cosine is -1 to 1 inclusive, so we just have to exclude the values that make it -1 and 1. So this one's tough to write as an interval, so we'll just write it out, and we'll say x is any real number, right? Use the pound sign for number, right? Except things like -2 pi, -pi, 0, pi, 2 pi, etc. in the positive direction, and etc. in the negative direction, right? So as long as it's not a multiple of pi, a integer multiple of pi, right, it's going to give us a convergent series. Okay, so that was A. Let's take a look at B. This is a good example. Okay, so what are we adding up here? 5 times the quantity x plus 4 over 3, all raised to the n power. Okay, so what are some of my terms in this series, right? So plug in 0, I just get 5, right? Plug in 1, I get 5 times x plus 4 over 3. Plug in 2, I get 5 times x plus 4 over 3 squared, etc., etc., right? So it looks like we're multiplying by this parentheses part every time. So a sub 1 is going to be 5, right? And my common ratio here is going to be x plus 4 over 3. That quantity, right, is what is being multiplied every single time. So what is the sum of my series going to be? Let me redo that. S's and 5s, bad combo for me. So that looks better. So this is going to be a sub 1 over 1 minus this quantity, x plus 4 over 3. Okay, and now let's see. So 5 will stay on top. Okay, I'm going to rewrite this 1 in the denominator as 3 over 3. So minus x plus 4 over 3. And now this will just take a couple of steps to combine. So we get 5 again, over, and let's see, 3 minus x minus 4. Got to distribute the negative here, right? So this is going to give me, what is that? Negative x minus 1 over 3. Okay. So I'm going to do two things here, okay? One, I don't like that 3 in the denominator of my denominator, right? So let me go ahead and rewrite this as 5 times 3 over, and now I'm also going to cheat a little bit here. I don't like negative x minus 1, so I'm going to factor out a negative from it. I can put it in front of the whole product and rewrite my denominator as x plus 1. Okay, and so this is going to give me negative 15 all over x plus 1. Okay, and that is going to be the sum for this series. Okay, now let's talk interval of convergence on this one, right? So again, right, r's absolute value has to be less than 1. So for this one, right, this tells us then that x plus 4 over 3, its absolute value has to be less than 1, okay? But here's what I can do. This 3 in the denominator, this does not affect the absolute value. So technically I can pull this out, and then I can go ahead and multiply it over to the other side. So I can go ahead and rewrite this then as the absolute value of x plus 4 is less than 3, because I can multiply it to the other side. And now this 3 here, right, now I'll shorten it up. This is the ROC. This is the radius of convergence. Okay, so real quick, I want to go back to the first example. I think I kind of messed up my explanation here. So the radius of convergence is not the entire inequality. It is just this numerical value. Okay, so basically, right, just, half the length of the interval of convergence, right? So in this case, it was 1, right? In this case, it is going to be 3, okay? Now, I can also find the interval of convergence, right? So let me set this up as a compound inequality. Negative 3 is less than x plus 4 is less than 3. Subtract 4 on both sides, and so I get negative 7 is less than x is less than, oh god, this is embarrassing, negative 1. And this, even though, did the question ask for this, right? It asked for interval? Yeah, it asked for interval of convergence. So the radius of convergence, that was bonus. Okay, right? Interval of convergence, this is what we wanted, the IOC. Okay, negative 7 to negative 1. All right. So again, right, halfway between these numbers is negative 4. And this brings us one more kind of key term here, okay, which is sometimes, right, these sorts of series we say are centered at a specific x value. In this case, right, because it's x plus 4, right, think of this as being shifted over to the left. So the last thing we'll say is that this is centered at x equals negative 4. Okay, so the convergence for this series is centered at around negative 4, right? So the numbers around negative 4. Well, how far away from negative 4 can we go? We can go 3 units in either direction, right? So what are the actual boundaries? That's the interval of convergence, negative 7 to negative 1. But the center is at negative 4. Okay, so all of this brings us to the idea of what this section is called and the heading for the last 3 days of notes, right, which is a power series. Okay, so a power series, right, is just a type of geometric series, okay, and they can be centered at either x equals 0 or at some other value x equals a. Okay, and in general, right, when we normally talked about geometric series in the past and geometric sequences, right, we were just dealing with numbers, right? 1, 1/2, 1/4, right? This one is a little bit different, right? Because all of the examples we've done so far have been using variables, right? When we're multiplying variables, right? Some form of a variable is my common ratio. This is what we call a power series, okay? So let's set this up then, okay? So sigma notation for my series here, right? C sub n times x to the n. So the c here is just some coefficient, right? Starting at 0, right? The first term is c sub 0, right? So just some coefficient, no variable terms, right? The next term, c sub 1, right, times x to the first power. The next term, c sub 2 times x squared, plus the next term, c sub 3 times x cubed, plus dot, 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 dot. Okay, for this type of power series, right, the convergence is going to be centered at x equals 0. Okay. Now, what does it look like when it's not centered at 0? When it's centered at x equals a, right, basically what you're going to kind of notice is kind of like a phase shift in your setup here, right? So like the last example we looked at had the x plus 4. Here it's a similar idea, right? X minus some value a. Okay, so the terms are going to be kind of set up the same way, right? Plug in 0, the first term is c sub 0. Plug in 1, I get c sub 1 times x minus a. And I think I'm going to put a little product symbol there just because the parentheses and c's look alike. Okay, plus c sub 2 times x minus a squared, right? Plus c sub 3 times x minus a cubed plus dot, dot, dot. Okay, so you're going to notice, right, the kind of like the phase shift almost, right? That's where the convergence is going to be centered. Okay, now let's talk about convergence. Okay, so with these types of power series, right, it is possible to have convergence for all x values. Okay. However, some of the examples we have seen show that sometimes convergence is only possible at some specific interval, right? And then there are other cases where convergence is only possible at that center x value, okay? So it all kind of just depends, right? Just kind of depends on what you have, okay? All right, so we'll call it a day right here, and I'll see you next time.